So a sprinter is shown before a race stationary. That's important in the set position. Now when it's stationary, what does that mean? That means that my initial velocity is 0 meters per second. So that's a key bit of information that I want to have there. Next part. Force F is the resultant force on the sprinter's fingertips. Okay, so that's force F is the fingertips. It's nice and easy, F and F. The reaction force Y on her forward foot, that's about here, that's 180 newtons. So I'm just going to add that because I don't want to figure out or get mixed up later on. So I'll put that there. And her weight W is 520 newtons. So I'm going to add that to my diagram as well. So I'll say here that that is 520 newtons. And X is the vertical reaction force on her back foot. So this is on her back foot. That's quite easily shown in the diagram anyway. So it says calculate the moment of the sprinter's weight, that's W, about her fingertips, and give an appropriate unit. So I'm going to get another mark for a unit. Okay. So the first thing I'm going to do is write down my formula. So I know that moment is equal to force times perpendicular distance, and that's about a certain pivot point. In this question, it's saying calculate the moment of the sprinter's weight. So I know the F, which is the weight in this case, so that is going to be 520. And about her fingertips, so that means that my pivot point is the fingertips in this case. And in this case, if I go perpendicular distance there and then up, that distance there I can see is 0.26 meters. So this will be 0.26 meters. And I'll just put here F because I've taken moments about F. So if I put that in my calculator now, 520 times 0.26, that will give me 135.2 newtons. Now let's look at the question again. Here, 180 is given in two significant figures. The 520 is also given in two significant figures. So that's the highest degree of accuracy in my question. So in this one, 135.2 to two significant figures would be 140. Ooh, and I made a little mistake here. This is newtons and the distance meters, that is meters. So Newton meters. So that's the first part of this question. We'll move on to the next part. It now says by taking moments about her fingertips again. Okay, so about her fingertips. Calculate the force on her back foot, mark X. So now it wants me to take moments about the fingertips, but this time calculate the force on her back foot. So now I need to consider, if I'm taking moments from F, I have three forces, because whenever you take moments about a certain point, that force doesn't count. So this F doesn't count if I'm taking moments about F. So I need to take into account the W, the Y, and the X. So I can see W is acting down, Y is acting up, and X is acting up. So, or another way of saying it is W is acting clockwise, Y is acting anti-clockwise, and X is acting anti-clockwise as well. Now we know from moments that there's a rule. So the conservation is basically conserving moments. So we say that anti-clockwise moments, or the sum of anti-clockwise moments, is equal to the sum of clockwise moments. So in this question, I have F. I can see from above that 520 is acting 0.26 away, and that is my clockwise moment. So I'm going to put that there. 520 times 0.26, which we've already calculated above, but I'll do the calculation again. That's my clockwise moment, and my anti-clockwise moment, I have 180, which is Y. So I'll just follow in order, 180, and that is acting at a distance of 0.41 meters away from F. So I'll do that at 0.41. That's one of my moments, that's anti-clockwise. Plus x, which we don't know the force of, but we know that it's acting 0.63 meters away from the fingertips. So I'll just quickly check that. F is there, W is acting 0.26 away, Y is acting 0.41, see that in the diagram right there, and X is acting 0.63 meters away from point F. So now all I have to do is calculate this and rearrange. Now, a good thing to do in the exam is always, some students put everything in the exam, on the exam paper in one go, and they just do the calculation in one go. You're bound to make mistakes, so I always calculate everything separately. That will give me 0.63x, and then 520 times 0.26, and I'm going to put in the actual value here, which is 135.2, just to make it a bit more accurate. So that will give me 0.63x, which is equal to 135.2, take away 73.8, and you can follow this on with the calculator with me. That will give me 0.63x is equal to 61.4. So I'm just going to take that up there because I'm kind of losing some space. So x is equal to 61.4 divided by 0.63, which gives me an answer of 97.4603. But again, I need to make sure it's into two significant figures. So I'm just going to round that down. That will give me 97 newtons. So 97 newtons is my answer. Now, kind of hidden it, but it's here. Next part, which says calculate the force F. So I'm going to go back to my diagram. I now know what W is, I know what Y is, and I've calculated X to be 97. So let's put that over here as well now. Now with moments, the good thing is that now to calculate F, I just have to understand that the forces acting upwards are equal to the forces acting downwards. That's making an equation. So from here, I'll just make my equation. The only force that's acting down is the W, so that means that, in fact, I'll do it like this. I'll say W is equal to, that's the one acting down, all the forces acting up, so that's F plus Y plus X. So we end up with our equation, W equals F plus Y plus X. We'll bring that down here now to apply into our question. So it says calculate the force F, so W equals F plus Y plus X. And from our above questions that we've answered, we already know what some of these variables already are. So we know that W is already 520 newtons, that was stated in question. F is what we're figuring out. Y, if we go back above to our question, we can see that it's 180, and X is 97. Let's clear that up for you. So if we just rearrange our equation in our calculator, we can see that F will give us 243 newtons. But we want it to two significant figures, so that will be 240 newtons. Put that answer there, and we're done with part A of the question. We'll now move on to part B. So part B says that the sprinter starts running and reaches a horizontal velocity of 93 meters per second. So we know here that is the final velocity. And at the beginning of this question, it said that the sprinter started initially at rest. So we can say that U is equal to 0. V is 9.3. And if we highlight the rest of the information in a distance of 35 meters, so that means that S is equal to 35. And the question is asking us to calculate her average acceleration over this distance. So I'll write down suva vertically in this form and substitute all the information that I know. So that is going to be S is 35, U is 0, V is 9.3, and acceleration is what I want to work out. So here I have to use my suva equations. Now what are my suva equations? What's the best one to use for these variables? So I'll write down some of the suva equations that we know. we know that V is equal to U plus AT. We know that S is equal to V plus U divided by 2 times T. We know V squared is equal to U squared plus 2AS. We also know S equals UT plus a half AT squared, and S is equal to VT minus a half AT squared. So I can see from my equations that I've written down that the one that's suitable for this is this one here, because I have my V, I have my U, I have my S, and I want to calculate A. So the first thing I always do is write down my equation. V squared equals U squared plus 2AS. I'm going to substitute all the variables that I know. So that will be 9.3 squared equals U squared, which is 0 squared, plus 2. A is what I want to calculate, and S is 35. So I'll simplify this equation. That will give me 9.3 squared will give me 86.49. 0 squared is obviously nothing, and then that simplifies to 70A. So putting that into my calculator, 86.49 divided by 70, the acceleration that I calculate, and the calculator will give me 1.2355 meters per second squared. But obviously I need to know, I have to follow the accuracy of the question. 9.3 was given to 2 significant figures. 35 again, 2 significant figures. So my answer is 1.2 meters per second squared. Then it says calculate the resultant force necessary to produce this acceleration. So I'll go back to my basics. In year 7 we learnt force is equal to mass times acceleration. I don't know my force. I know my acceleration is 1.2, and mass I can calculate because I initially found out in the question that her weight was 520 newtons, and we know that weight is equal to mass times gravity. So 520 is equal to m times 9.81. And if I rearrange that, my mass, I calculated 520 divided by 9.81 will give me 53.00 kilograms. So we'll just leave it as 53. So we'll plug that into this equation here. And so therefore F is equal to 53 times 1.2, which will give me solid answer of 63.6 newtons. Again, I need to make sure I follow my 2 significant figure rule. So this would be 64 newtons. Now in a question like this, where I have to look at the accuracy of the question, I should always look at going past in the little parts and see, have I followed that rule? So 64, fine. 1.2, good. 240, good. I put my units there. 2 significant figures, good.